Hello everyone. I hope you all are good. So I welcome everyone in AIET 5 class 12 NEET question discussion. Okay. So I hope you all must have attended the test with utmost sincerity and you all must be looking for solution of some questions. So I just wish I have covered all those questions. So let's get started. Okay. So the very first question that we are going to solve is question number 5 of your paper. And this topic I have dealt with very much recently. The width of the depletion region in a PN junction diode is. So in PN junction diode width of depletion region. So हमने देखा था if this is our PN junction region, if this is P side, this is N side, and on P side there will be a layer of negative charge done, and on N side there will be a layer of positive charge done, and this region is called depletion region. Okay, in forward bias what we do, if this is forward bias, then we connect P to a positive terminal of the battery and N to negative terminal, and in reverse bias we do the opposite. And in forward bias, what happens? This depletion region thickness will what? That will decrease, and in reverse bias, it will increase. So, depletion region width increased by reverse bias, yes. Increased by forward bias, no. Sorry. Decreased by reverse bias, no. Independent of bias voltage, no. It will depend, right? So this is also false. So correct option will be what? Correct option will be A. Now let's move on to next question. So light appears to travel in a straight line because. So in wave optics, like we have discussed ray optics, and when we will start ray optics or at the end of ray optics, some people discuss. So there we will see that it is a spreading of light that decides if light will be taken as a ray or if light will be taken as a wave. And how we define the spreading of light? So suppose Carlo, there is an obstacle and this is the obstacle, its size is A, suppose. So what will happen if light is falling on this obstacle like this? So if light is encountering any obstacle, what will happen? It will bend around the corner. That is the process of diffraction that we will read in wave optics. So, and if this obstacle size is very large, then it will reflect back simply. And if this obstacle size is very small, then what will happen? It will diffract. But the question is how much spreading will happen? That will decide if light is behaving as a ray or as a wave. Done. So that we will see, like if A theta is equal to, suppose कर लो lambda. So theta equal to lambda by A. So this is angle of what is that called? Means the angle in which it is getting spreaded. Okay, lambda by A. And if lambda is very small, then what will happen? This theta will be very small. Then, so light appears to travel in a straight line because this spreading is very little, and this spreading will be little when ये little कब होगा जब हमारा when lambda will be what? Lambda will be very small, and also when A will be very large. Done. But if A is a small, then lambda will decide if light will appear to travel in a straight line or not. Done. So here, which option is going to be correct? Light is an electromagnetic radiation. It is true, but it doesn't explain our question. Okay, so this statement can't be true. Frequency of light is very small, not always. It will depend on which color of light we are talking about. So this is also false. Velocity of light is different for different colors. Yeah, it is true, but this fact don't explain our question. So again, this is also false. Wavelength of light is very small. So in general, wavelength of light is what? Very small. And if this obstacle size is small, it can be taken as the angle in which it is getting spreaded is also small. So correct option should be what? D. Done. Velocity of light won't explain this question. Frequency of light is not going to explain it. Done. Over. Now let's move on to next thing. Okay. So next question is what? Next question is before your uh, or on the screen, you can see. So two metal plates, this is question number 7 of your paper. Two metal plates are uniformly charged. So these two are uniformly charged and potential difference is given. If this is V1, this is V2. So potential difference is 36 volt. So delta V is given, that is your 36 volt. Now, this separation is also given, that is 0.01 meter. Then plate 2 is at higher potential. So V2 is greater than V1. Now, what is happening? An electron is released from rest from the inner surface of plate 1. So near plate 1, there is an electron and that electron is at rest. And what will happen to this electron if it is kept here at rest? Just understand the concept. So here V1 is V2 is greater than V1. What will be the direction of electric field? We already know that electric field is in the direction in which potential decreases the maximum. So if potential is decreasing in this direction, then electric field direction will be like this. Done. And if this is electron, on electron, force will act opposite to the direction of electric field because electron is a negative charge. So what is going to happen here? Now, I have also explained in electrostat that if there is a Q amount of charge and if you are allowing that Q amount of charge to travel freely in a region which has potential difference, then that charge will get accelerated. Done. And its kinetic energy will increase because we have learned that potential is what? Work done per unit charge is equal to what? Potential difference. So if there is a potential difference between the region in certain region and if charge is flowing in that region, a work will get done on the charge and that work done will be equal to q dv, and this work done is going to increase the kinetic energy of charge. So this is whole the concept. And I've also told you how you will write the energy. So energy will be equal to energy gained by a charge particle, in this case will be q delta v. Then and this energy will be in the unit of electron volt, right? And if we have to convert this energy into joule, what we will do, we will multiply it with 1.6 into 10 to the power minus 19 coulomb. Okay, so that thing we are going to do now. What is the speed with which it will it hits plate 2? So here its energy is what? Here its energy is 0, and here its energy will be because what? Because this electric field is doing work on it. So whatever work is getting done on the charge, that will be responsible for the increase in kinetic energy of the charge. So यहाँ पे आप क्या लिखोगे? Half mv square, that is gain in kinetic energy of the charged particle, will be equal to qv. And here q is electron. So q is a single electron and v is your what? V will be your potential difference here, and that is your 36 volt. Then so here half mv square we have written, its unit of energy will be joule and it is in electron volt. We need to convert it. So we will be writing the value of charge, that is 1.6 into 10 to the power minus 19. चलो ये काम करते हैं. Now half into mass of electron is how much? That is 9.11 into 10 to the power minus 31 into V square will be equal to how much? E का value आप put करो 1.6 into 10 to the power minus 19 into delta V, that is your 36. So this is going to be the value. Now V का value हमें निकालना है. अब आप carefully इसको solve करो. So if you are going to do it, what will happen? 36 into 2. ठीक है? 36 into 2. This 2 will go here. 36 into 2 into 1.6 divided by 9.11 root under and 10 ka power. Let's manage that here. This is minus 31 and this is minus 19. So this will become how much? This will become into 10 to the power 12, right? So 19 and 12 will get added to 31. So this is correct. Then calculation is correct. Now you need to solve it. अब आप इसको solve कर लो. So 9.11, if I go with the approximation, क्योंकि where we go for approximation, that's also a thing. ठीक है? So here you see option A, 3.6 into 10 to the power 6, 7.02, 1.87, 32. So no option is very close. Each option has a difference of 2 unit, right? Here also there is a difference of some near about 2 unit, and 3.6 and 7.02, almost half. So there is a considerable difference. And if there is a considerable difference in the options, you can go with a small approximations. So in place of 9.1, what I'm going to put here is 9. Okay. So what it will become? This is 9, 36 into 2. So that will become, this is 6 by 9. So that is 36 by 9. So if you will take 36 by 9 out of root, it will become 6 by 3. And inside will remain what? This is 2 and this is 1.6. So 1.6 को आप क्या लिख सकते हो? 1.6 by 10, 2 by 10 क्या हो जाएगा? 1 by 5. और 16 को बाहर लाओगे, again this will become 4. So here it is 1 by 5 into 10 to the power 6. So this is 4 into 8, 8 divided by root 5 into 10 to the power 6. Now again, if I take root 5 equal to 2, क्योंकि मैं अगर उसको 4 से approximate करूं, root 4, 2. So this will be 4 into 10 to the power 6. And that is close to which option? That is close to which option? Option A. So correct option will be what? Option A. Okay. I hope it is clear. Now, let's move on to the next question. And this question is just a recall thing, a formula-based question. If you remember the formula, you will be able to answer it. Energy of electromagnetic wave in vacuum is given by which relation? Then, so in electrostat, in magnetism, we have studied that energy means if there is electric field in certain region, and also if there is a magnetic field in certain region, then in this region, energy exists, and energy per unit volume we write like in electric field half epsilon naught E square, and similarly energy per unit volume in magnetic field we write as B square by 2 mu naught. Okay, so which option, if there is both electric and magnetic field in the same region, these both energies will exist, and so the answer will be half epsilon naught E square by 2 plus B square by 2 epsilon. So which option you're going to tick? E square by 2 epsilon naught? No formula, no such formula. Also, this is not the correct, this one is correct, but this is wrong. So this whole, it makes whole wrong. And this one is correct. Again, I must say here in the question, it should have been there like the energy stored per unit volume. Energy per unit volume of electromagnetic wave in vacuum is given by what relation? And but still, it is somewhat understandable because from the option you can see it's just talking about energy per unit volume. So sometimes when you get confused by question, you can get informed by the options. So always read options carefully. Okay. Chalo. So now next question. This is a question of compound microscope. This thing also we have covered in our classes. Now in a compound microscope, focal length of two lenses. Then in compound microscope, which are two lenses, objective lens, eyepiece. I have told you, objective lens will have a small focal length. Eyepiece will have a comparatively larger focal length. So their focal length are given. This is 1.5 and this is 6.25. An object is placed at 2 centimeter from objective lens. ठीक है, ऑब्जेक्ट कहाँ रखा हुआ है? इट इज केप्ट एट 2 centimeter from the objective. Definitely object we place before objective lens. So here it is now, and the final image is getting formed at 25 centimeter from the eyepiece. Now, if you remember compound microscope, I have told you final image has two cases. One case is your final image is getting formed at infinity, and another case is final image is getting formed at least distance of distinct region. And in both cases, image getting formed is what? Virtual, right? So here what is happening? Final image is getting formed at 25 centimeter. It means at least distance of distinct region, right? So suppose Carlo through first lens, image is getting formed at here. This object will act as, this image formed by first lens will act as an object for the eyepiece, and this eyepiece will form the image of what? Uh, this first image finally at least distance of distinct vision from eyepiece. So this is 25 centimeter. You can see here clearly. This is inverted image and final image getting formed is also inverted. So they are virtual images. You know, both are erect in that sense. Okay. So now let's see. Let's say this image distance for this is, sorry, object distance for this is B. So if you're going to put the formula, agar aap formula lagao, we can calculate this V. So this is a lens formula 1 by V minus 1 by U equal to 1 by F. Now 1 by U is object distance. This is not known. चलो मैं इसको U रखती हूँ, confusion नहीं. ठीक है, 1 by V is known, right? 25 centimeter, and this is formed on the same side of the lens. So take sign convention properly. 1 by V, V value is 25, plus 25 or minus 25. Definitely plus 25, minus 25 if image is getting formed on the other side. Otherwise, you're measuring distance from the pole in this direction, and incident light on second lens is in this direction, right? So this will be minus 25 minus 1 by U. Since this is a convex lens, focal length will be taken as positive 6.25. Now if you calculate 1 by U, this will become 1 by 6.25, ठीक है, plus 1 by 25. Now solve it. इसको आप 100 ऐसे कर लो. 6 to 5 है my favorite thing to make denominator equal. So this I will multiply with 25 and also divide and multiply with 25, right? So what it is going to become 1 to 5 divided by 6 to 5, and this will get cut by 5 times 1 by 5 with negative sign क्योंकि यहाँ पे -1 by U. ठीक है? So U is -5 centimeter. It means this is sign convention will also be negative. That is why negative answer we are getting, right? So this U is 5 centimeter. Now we have to calculate length, right? So length of the microscope. Length of microscope will be this. So this U is known. Now can we calculate this image distance for the first lens? We can do that because object distance is given for the first case also. So above लिखो 1 by V minus 1 by U equal to 1 by A. In this case, V is not known, U is known, and U value you will take as what? This is your how much? 2 centimeter. 1 by minus 2, and that is equal to 1 by 1.5, right? So calculate it now. 10 by 15 minus 1 by 2. My favorite thing, make denominator equal 2 into 15, and this is 15, 30, 15 into 2, and here 2, 30. So 20 minus 15, that is 5 by 30. And 5 by 30 means how much? This is 1 by 6. So V is how much? 6 centimeters. So this distance is how much? This distance is going to be 6 centimeters. Okay. Is it clear? Okay, done. Done. That is the habit of class actually. That is why I asked. Sorry. So V equal to what? 6 centimeters. So this is how much? This is 5. This is 5 and this is 6. So total distance is how much? 5 plus 6 centimeters. So answer will be what? 11 centimeters. So answer will be B. I hope it is clear. Now let's move on to this question. There is one thing. The question that looks big happens to be almost very small in terms of solving. Okay. So this question seems like too long. Let's read it. A box P and coil Q. There is a box P. So आप box P बना लो. And there is a coil Q. Coil Q you will make like this. Coil Q. Done. They are connected in series. So they are connected in series with an AC source of variable frequency. AC source of variable frequency. The EMF of source is at 10 volt. Its EMF is 10 volt. Box P contains a capacitance of 1 microfarad in series with resistance of 32 ohm. So what is inside box P? So inside box P there is a capacitor and there is a resistor. Okay? Capacitor capacitance is 1 microfarad and resistance value is how much? 32 ohm. Now let's move forward. Coil Q has a self-inductance of 4.9 millihenry. So its L value is 4.9 millihenry. And just get accustomed with this thing. If you're getting a coil that is also made of some material, it will have resistance. Then, so often in question, you might have encountered if there is a coil, it has only inductance. In that case, we have neglected its resistance. So there may be two cases. Either you are just given the inductance of the coil or you're given the both. I mean inductance and resistance. Done. So here it's given the both. And its value is how much? It is 62 ohm. Done. And this is in series. Means this coil Q you can write like this. Like this. Okay, so it has inductor of certain inductance and it has a resistance and they're in series. So this is the question. Now, the frequency is adjusted so that maximum current flows in P and Q. Maximum current case is this. Find the relation between impedance of P and Q at this frequency. So which will be higher. Now just look at the question very calmly and very carefully. So inside box P, there is a capacitor, there is resistor. Q consists of inductor and resistance. So अगर मैं इस circuit को फिर से बनाऊं, so this circuit will look like there is a capacitor, there is an inductor, and there is a resistor. Resistor value total is 32 plus 68 ohm. Then, so this is simple and a LCR circuit. And in an LCR circuit, we already have studied that current is maximum when XC is equal to XL. It means inductive reactance and capacitive reactance are equal. This is this XC 1 by omega C and this is XL omega L. These two are what? Equal. Then only we will get maximum current, because for maximum current, net reactance of the circuit need to be small, and net reactance will we write as what? R square plus XC minus XL ka whole square root over. Done. And this Z will be minimum if XC is equal to XL, because in that case, this term will reduce to 0. So if current is maximum, yeah, current is maximum, Z is minimum, means XC is, because current value is how much? Current value is equal to V by Z. So definitely, if Z is minimum, current is maximum. Z minimum means XC is equal to X. Now, if XC is equal to XL, means this capacitor reactance is equal to this inductor's reactance. Done. Now we are talking about reactance of or impedance of P and Q. So what will be the value impedance of P? Impedance of P अगर आप लिखोगे तो आप उसको कैसे लिखोगे? So ZP you will write as XC का square plus 32 का square. This is ठीक है. And what will be ZQ? That will be written as XL का square plus what? Plus omega L, sorry, plus how much resistance is that? That resistance is 68 ka square. So which will be higher, ZP or ZQ? Because XC and XL are equal. So definitely ZQ is greater than ZQ. So correct answer will be, you just needed to understand the question to solve the question. Question is very easy. Okay. Now let's move on to the next question. So this is your next question. Voltage across an electric bulb, it decreased by 2%. Assuming that resistance of filament remains same, the power consumed will be. Now, power and voltage has a relation of what? Power is written as V square by R, because in this question, information is given about resistance, about voltage. Nothing is talked about current, right? Power can also be written as I square R. But to solve this question, we will move ahead with this formula, because in the question, it is saying voltage is decreasing by 2% and resistance is remaining the same. Now, if it is 2%, we can solve it with the help of that error formula. Done. If percentage increase or decrease is of the range of 1%, 2%, 3%, kind of near about this, we can use that error thing. And what is that? Just say if you go on and write error for relative error for P, what you will do? First, you will write P as V square R ka power minus 1. Then you will write delta P by P is equal to 2 delta V by V minus delta R by R. So this is how we write it. Then, since percentage decrease is not that much high. It's not 10%, 11%, 12%. It's not 8, 9%. It's not that much significant. It's just 1 or 2%. So we can go with this thing also. Then don't do this thing for higher increase in percentage. So higher percentage increase. Okay. So अब आप यहाँ पे देखो delta P by P. Now, delta P by P will be equal to 2 delta V by V. So that is equal to 2%. So I will write it 2%. Okay. और अगर परसेंटेज निकालू तो यहाँ 100 करोगे, यहाँ 100 करोगे और यहाँ भी क्या करोगे 100, right? So this is 100 and that will give us percentage, right? Now this delta R is 0 because in the question it is said that resistance is remaining the same. So this is 0 and this will become 0. So percentage change in pressure is how much? 2% it is getting decreased. So we will attach a minus sign here because this is minus 2%, right? Minus sign to indicate decrement. Okay. So power will decrease by 4% or increase by 4%. Power will decrease by 4%. And that is why correct answer will be what? It will be C. Okay. Now let's move on to the next question. There is an electron and that is launched with a velocity V in a uniform magnetic field B. Angle theta is between V and B. So let's say this is the direction of magnetic field. This is the direction in which this charged particle is getting launched. Okay. And this charged particle is nothing but this is electron, right? This is what? This is your electron. Now let's see what it is asking. B lies between 0 and pi by 2. So this angle is acute angle, somewhat means just greater than 0 and just less than pi by 2 values if we are taking, then in between these two it's lying. But it's exactly not equal to 0, it's exactly not pi by 2, but in between these two. The minimum and maximum magnitude of magnetic force. So magnetic force formula is how much? QV cross B. And it is equal to QVB sine theta. Done. So maximum, F max will be when theta will be 90 degree, but here angle is between 90 and 0. So near about 1 it will be. Done. If angle won't be pi by 2, just less than pi by 2 angle if we are taking, then also sine theta will be close to 1. And so we can say maximum force will be equal to QVB. And what will be your the minimum and maximum force? So what is going to be the minimum value of this force? In that case, sine theta can be 0. Done. So because theta is what? Theta is acute. Done. And it is asking the minimum maximum magnitude it is talking about. It's not talking about the sign of that force. Done. Clear? Eh? So if we talk about magnitude, its maximum value will be when theta is pi by 2 and its minimum value we can't say minus QVB. Okay. Why? Because here it is talking about magnitude. Okay. So F max is QVB and F minimum will be what? 0. I hope you all must have done it. Just I have included this question because you can see how much easy questions you have chance of getting in exams also. Okay. Chalo. Next, move on to the next question. And I must say your paper was very easy. A ray of light is incident at the glass water interface at an angle I. Okay. If it emerges finally parallel to the surface of water, then the value of mu z will be what? Mu z we have to calculate. Now see here, light is moving from here and finally it is going like this. Done. So if we apply Snell's law at this surface, or if suppose at this surface we are applying first, that is at point 1. So at this point, if you apply, so mu w sine r will be equal to what? Mu air, that is 1 into sine 90. Okay. आप यहाँ sine 90 लिख लो. What value you are going to get for sine r? Sine r will be 1 by mu w and mu w is 4 by 3. So this is 3 by 4. Now we have the value of sine r. Now apply Snell's law at surface 2. If you're going to do that at surface 2 at 1, and now I'm going to do the same thing for 2. So what you will do, sine I, you will write here. Done. So mu glass sine I will be equal to how much? mu water sine R. And mu water sine R is equal to how much? You can see here, it is equal to 1. So this became equal to 1 mu g sine I. So mu g is equal to how much? 1 by sine I. So very easy question. Just need to put the formula and get the answer. So B will be your correct answer. Okay. Now let's move on to next question. LCR series circuit, alternating EMF En, current I are given by the equations. Average power dissipated. So what is the formula for power dissipated? This is VRMS, IRMS cos phi, where phi is what? Phi is phase angle between voltage and current. Now, current voltage equation is given, current equation is given. One important thing to notice is कि voltage equation is given in term of sine, I also is given in term of sine. Both should be in term of sine to compare their phase. You can't compare their phase if one is in sine and another is in cos. If that were the case here, what you needed to do, either you needed to convert sine to cos to make both cos, or either you needed to convert cos to sine to make both sine. Done. But here both are sine. Done. So we can compare their phase. Now, what is the phase of voltage? Phase of voltage is 100 T. What is the phase of current? Phase of current is 100 T plus pi by 3. What is the phase difference? 100 T plus pi by 3 minus 100 T. So that is pi by 3. Now, you need to put values here. So, phase difference we have calculated. That is, pi value is how much? Pi by 3. Now, what is VRMS? In this equation, this is V naught, that is amplitude. And here it is I naught, that is amplitude of current. And this is amplitude of voltage. What is the relation between RMS value and amplitude value? If equation of voltage is in plain term of sine or cos, then VRMS is equal to V naught by root 2. So VRMS 100 by root 2, IRMS 100 by root 2, cos phi, cos 60 degree, that is half. So what answer you are going to get? This will become 4, and 4 से ये 25 times में चला जाएगा. So this is your how much? 2500. Again, one thing we have missed on, that is current is given in terms of milliampere. So IRMS I have written 100 by root 2 milliampere. Let's convert it into ampere. So this is this much watt. So this is 2.5 watt. This is the power. So answer should be what? D. Okay. Now, this is a simple question of potentiometer. I hope you all must have done it. In a potentiometer circuit, what will be the length AJ for which galvanometer shows null deflection? So, very beautifully, I must say, I have taught you instrument in electricity. So, I hope you all must have done it. If you have not done it, I will be really disappointed. So I have told you, if potentiometer circuit you have to solve, treat it like two circuits, as sum of two circuits. So first circuit, potentiometer circuit. यहाँ पे आप लिखो, this is 5 volt and this is your resistance 4 ohm, and after that there is a wire. ठीक है? So first circuit, I have told you, draw the first circuit, solve the first circuit first. Okay. So its resistance is 2 ohm and its length is 100 centimeter. Solving first circuit means calculate current there. So resistance of AB is 2 ohm. It is 4 ohm. This and AB are in series. So resistance of the circuit is 6 ohm. Current in the circuit will be 5 by 6. So this is current. Now, what will be potential gradient on AB? That is potential drop on AB per unit length. So potential drop on AB will be I into 2. So that is V on AB is 2 ohm into 5 by 6. So that is equal to 5 by 3. And its total length is 1 meter. So 5, that is VAB by L, will be equal to 5 by 3 itself. Right? So this is the potential gradient. Now, we have to balance. Secondary circuit is what? Secondary circuit is this circuit. Done. And there is a galvanometer here. So secondary circuit is this simple. 1.5 volt. So secondary circuit, this is primary, I call it primary. This is secondary. This is an open circuit. You don't need to solve the circuit. This is open. Current is 0, right? So it is getting balanced at J point. It means potential of AJ potential difference of which, just give me one sec. So potential difference of this AJ will be equal to that of this. No current is flowing. So potential difference across cell will be equal to its EMF, that is 1.5 volt. So potential drop on AJ is 1.5. Now let's say the length of AJ is L. So L into potential gradient, that is 5 by 3, must be equal to 1.5. Now let's calculate it. L will be equal to 1.5 into 3 by 5. So this is 0.3 and this is equal to 0.9 meter. So answer will be what? 0.9 meter. Correct answer is C. I hope it is clear. Now this is a question of Zener diode. So two Zener diode A and B. There are two Zener diode. I have taught, I don't have like, uh, I didn't have, I guess, yeah, I didn't have taught this Zener diode, but I have discussed breakdown thing. Done. So it will be understandable, I guess. Two Zener diode A and B having breakdown voltage 6 volt and 4 volt. Okay? And they are connected as shown in the circuit. Output voltage V naught variation with input voltage is best given by which graph? Just see here things. Zener diode. Zener diode is a voltage regulator. And if it is given that through Zener diode breakdown voltage is 6 volt. यानी कि Zener diode का symbol ऐसा होता है, ऐसा कुछ ऐसा बनाते हैं, ठीक है, ऐसे ऐसे होते हैं, ठीक है. So this is your Zener diode. Done. So this is a Zener diode and the maximum voltage drop across it will be 6 volt. Almost it will remain constant at 6 volt. And through this Zener diode, it is given in the question 4 volt. So we are asked what will be the potential drop across the load, that is output voltage. How will it change? So suppose कर लो V in is changing from 0. So 0 से V in is increasing from 0. Then what will happen? As it will become 1 volt, across it voltage will be 1 volt. So across it voltage will increase up to what? Across this Zener diode voltage will increase up to what? 4 volt. But this branch also has some resistance. Suppose कर लो ये, why I picked this question, I will let you know. So suppose कर लो this question is like this, ठीक है, ऐसा है one branch and another branch again there is only Zener diode, no resistance. Then and its maximum voltage breakdown voltage 6 volt and it's 4 volt and then there is a load here, okay, and it is asked that what will be the voltage variation across load. So as we will increase input voltage as we will increase across this Zener diode it will increase, across this Zener diode it will increase, and these two are in parallel. Now you just see here, this through this Zener diode voltage can't be greater than 4 volt. So across it voltage can't be greater than 4 volt. So across it also voltage will not go above 4 volt. So if the diagram were like this, our correct option will be C, because voltage V in will increase, and after that it will become constant at 4 volt. Done. But here what is the case? In second branch there is also a resistance, so across it also voltage will drop. So there is a chance even if voltage has become 4 volt, more input voltage will increase, because beyond 4 volt whatever voltage is increasing will drop across 100 ohm resistance. Okay, so across it also voltage can go up to 6 volt. Again beyond 6 volt it can't go, because this is a Zener diode and across it breakdown voltage is 6 volt. So even if you are increasing input voltage, that won't appear across this Zener diode and hence not across the output voltage, because all are in parallel. Then so voltage will increase up to 4, again it will increase and it will become constant at 6. So correct option will be D, and if there were no 100 ohm here, correct option would have been C. Okay, so I have explained it. Now let's move on to this circuit. For circuit shown in figure, current must not exceed, current का वैल्यू कितने वैल्यू से ज्यादा नहीं होने चाहिए. Over. So how we are going to solve it? You just see here, different resistance are given. Now there is a resistance of 250 kilo ohm, and across it maximum power drop can be 1/4 watt. So suppose कर लो, what maximum current will go through this resistance. Done. So power को आप क्या लिखोगे? I square R. ठीक है. Power is how much? 1/4 watt. I square, we don't know. Resistance is how much? 250 into 10 to the power 3. So I square will become equal to how much? 1/4, 25 into 10 to the power 4. And this 25 into 4, this is your how much? 100. And this will become 10 to the power 6. So 10 to the power minus 6, I will be 10 to the power minus 3 ampere. That is 1 milliampere. So through first resistance or register, maximum current will be 1 milliampere. Now let's see what will be this case with second. So अब आप second को draw कर लो यहाँ पे. This is 10 kilo ohm and this is 1/4 watt. Again do the same calculation. Sorry. So this is equal to 1/4 watt. ठीक है? And I maximum current that it will allow, I square into R, that is 10 to the power 4. Okay. Now, what will be the value of I square? It will be 1/4 into 10 to the power 4. So this is equal to, अगर मैं I निकालूं, so I will be equal to 1/2 into 10 to the power 2. एक काम करो, 10 लिखो, यहाँ भी 10 लिखो. So this will become 5 milliampere. So maximum current that second register can sustain is how much? 5 milliampere. Over. Now let's go on to the third register. Again, in the exam, you will get the clear idea of just by looking at the resistance value that where the current is going to be maximum in these three cases. But since I'm solving, I need to solve. Now let's go with the third case. Third case में क्या है तुम्हारा? 1 ohm है, 10 kilo ohm. 10 kilo ohm is the resistance, 1 watt is the power. So 1, this is 1, I square, and this is 10 to the power 4. So I square is how much? 10 to the power minus 2, यानी कि I is equal to 10 milliampere, because you will do here 10 by 10. So, sorry, yeah, 10 by 10. So this will become equal to how much? 10 milliamp. Done. So, but these three resistors are in series. Done. So maximum current that it can sustain is 1 milliampere. Maximum current that it can sustain is 5 milliampere. Maximum current that it can sustain is 10 milliampere. Suppose if 5 milliampere goes through, first resistor will not sustain it. It will break or it will melt. Done. So we need to allow such current which can be sustained by all these three resistors, and that value will be 1 milliampere, because 1 milliampere is just lower than the allowable limit of both other resistors, and also it is equal to the allowable limit of first resistor. So this is the most safe. So maximum current that we can allow to pass through these three resistors will be 1 milliampere. Chalo. Now let's see this question. In which of the following circuit is the current flowing maximum just after the switch AC is closed? So question is very simple. I just wanted to remind you people of certain things. That is, if there is an inductor in the circuit, and if that's the case, then just after closing the circuit, inductor will behave as insulator. Done. Inductor will behave as insulator. So that's the key point to solve this question. Now, in first case, if we close the switch, it will behave as insulator. So there will be a break in circuit and no current will flow. So in first case, no current. Now in second case, the moment we switch, this will act as a insulator, sorry. So it will get out of the circuit, then, and our circuit will simply become a part of 2 resistor and 1 voltage. So current here will be how much? E by 2R. And here also it will go away. So if this go away, this is also the part of it. This is also in series with inductor. So if there is an insulator connected in series with a resistor, they hold together or they together will become also insulator. So ये पूरा हो गया तुम्हारा insulator, done. Because if you draw the circuit ना, मैं इतना fast इसलिए कर रही हूँ because I'm just assuming you people have basic knowledge of circuit. Okay, so circuit कैसा दिखेगा, मैं एक केस बना देती हूँ ऐसा, done. Because this inductor will behave as insulator. Insulator means break in the circuit. And if current is flowing like this, we have switched on the current. At this juncture, current will go here, not here, because here there is no complete path for current to flow. So circuit will be this only. And if this is the circuit, current will be E by R in this case. So just current flowing is maximum in which case? In circuit 3. So correct answer will be what? C. Now, the potential at point A will be what? So this is the point A. At point A, what is going to be the potential? कितना होगा? अब आप देखो ध्यान से, when I was teaching capacitor, I have told you a concept of isolated system that is not connected to any voltage point or voltage source, right? So if you see here, this is the capacitor and this is this. Again, this is the capacitor, this is this, and this is the capacitor and this is this. If you carefully see, these three combinations of capacitor, these three, these three plates are not connected to any voltage source. This plate is connected to voltage source and its voltage is 60 volt. Similarly, this plate is connected to 10 volt and this plate is connected to 20 volt. But other plate of all these three capacitors are connected to a common point A, and that is not biased, or that is not supplied with any voltage. So these three makes together isolated system. And I told you in isolated system, what happens? What happens? Charge will remain conserved. So initially, if these three systems are not connected to any voltage source, and finally also not, so charge will remain zero. Then, so just assume that here the voltage value is X. And if here the voltage value is X, what will be charge on this plate? If you see, sum of charges on these three plates is going to be what? 0. I'm saying. क्यों? In ये इसको plate 1 मानो, ये 2, ये 3, ये 4, this is 5, this is 6. So sum of charges on 2, 4, 6 will be 0 because 2, 4, 6 are not supplied with any or not connected with any voltage source. Then, so let's calculate charge on plate 1. So this is 10 volt. Potential difference 10 minus X. Done. And capacitance is C. So charge will be how much? Q equal to CV. 10 minus X into C. What will be charge on fourth plate? This potential is 60. 60 minus X potential difference into C. What will be charge on plate 6? That is, this is 20. 20 minus X into C. And this is equal to 0. Done. So if you're going to see, C will get cancelled. And this is 10 plus 60 plus 20, that is 90. 90 minus 3x is equal to 0. So x equal to how much? It is equal to 30. So what will be the potential of A? That will be 30. So correct answer should be what? It should be B. Now, there is an inductor, 20 millihenry. There is a capacitor, 100 microfarad, and the resistor 50 ohm. They are connected in series. So there is an inductor. There is a capacitor and there is a resistor, okay, and they are connected in series, and in turn they are connected to a variable source like this. Now the power loss in the circuit, as I have said, this question you need to solve. So as I have said you one thing, that is power in LCR circuit or any circuit, any what is that called, alternating circuit or any AC circuit, I must say, what that is written as VRMS, IRMS cos phi. Now, in this question, what you need to do is, you need to just work on very much carefully. IRMS is not given, right? In the question, it's not given. Is it given? No. But V is given, V naught sine omega t. So this is V naught. VRMS will become equal to how much? 10 by root 2. Now this is omega. Okay. So VRMS is known. IRMS is not known. How we will find out that? That's the only thing you needed to calculate here. So this is a circuit, right? And its impedance will be equal to what? Z, and Z is equal to how much? R square plus XC minus XL ka whole square ka root over. So this is Z. Now, uh, what you can do here, you can reduce this circuit like this. Its impedance is Z, and this is circuit. Done. And in this circuit, if Vrms is known, then Irms will be equal to how much? Or you can say Vrms, voltage drop across this, RMS voltage drop will be equal to how much? Irms into Z. We can write, right? So Irms will be equal to how much? Irms will be equal to Vrms by Z. And that is cos phi. Now, phi is also not given in the question, but we can calculate phi because we know how to do it. कैसे करते हैं हम? उसके लिए we need to draw the triangle. So draw the triangle, and in triangle this is Z. I have told you this is R, and this is XC minus XL, and this is your phi. ठीक है? So cos phi is equal to how much? R by Z. So write here the values. Vrms का square by Z into R by Z. So answer will be what? Vrms, that is given in the question. Z ka square into R. Now what will be Z ka square? R square plus XC minus XL. Now what you need to I'm not going to do the calculation here because that will be just killing of time. I just wanted to explain how you will reduce this to this form. Okay. So XC you can write as 1 by omega C. C value is already given 100 microfarad. Omega value is 314. Put the values. XL, omega L. So 314 into L value is how much? 20 into 10 to the power minus 3 ohm. If I put here the values, so 1 by omega 314, C ka value is how much? That is equal to 100 microfarad, yani ki 10 to the power minus 4 farad. So just solve it, put the value, you'll get the answer. Then now there is a U-shaped wire having current I, and that is placed in a region of magnetic field as shown in the figure. Magnetic force acting on the wire. So if you remember, magnetic field force acting on a current carrying wire in magnetic field, FB is written as IL cross B. Done. And this wire is like this, like this. This is the horizontal part. And our magnetic field is in this direction. So if I consider about force acting on this horizontal part, and also this horizontal part, you can say L direction we take as what? In the direction of current. So for this part, current is flowing in this sense. So direction of L is in this sense, and direction of B is in this sense. So angle between L and B is what? 0 degree. And here L cross B, yani ki ILB sine theta. And if theta is 0, this will become 0. So force acting on these two portions, these two linear portions will be 0 because angle between length and or current vector and magnetic field is 0. Now comes the turn of this thing. I have told you how to calculate force acting on a wire that is not straight, that is curved in some sense. So again, you need to calculate L vector. L vector, you will calculate here how? This is not a straight wire, right? So I have told you do one thing, join the initial and final point of the wire. So this is the initial and final point of wire. So this will act as a L vector. This will act as a L vector. Now, if you put the values, I, current flowing through this is I. So I, L ka value kitna hoga? This is the diameter. And here, L-shaped wire carrying current I, its radius is given in the question or not? You just see here. Radius is given R. So length will be equal to how much? It will be 2R into B into angle between L and B is how much? This is L and this is B. Angle is 90 degrees, sine 90. So answer will be 2I RB, and that is C. So correct answer will be what? C. So in this question, we can see we have to calculate force and torque acting on this wire that is kept in a magnetic field. And how we will solve this question? So we know that force acting on a current carrying wire is how much? I L cross B. And what is the torque formula? That is M cross P. What is M? That is magnetic moment. Then, so we know this formula. Now the question is how to apply this formula here. So for force acting on current carrying loop, I have discussed with you two cases while I was teaching this topic. So suppose there is a uniform magnetic field, that is inward magnetic field here. I have taken direction to be inward. Now, in this inward uniform magnetic field, I am placing a closed loop. Okay? And if current is flowing in this closed loop like this. Now, what will be the force acting on it? Then, further, in previous questions discussion, I have also told you how to calculate L. Like if this is not a closed loop, like if the loop is like this, sorry, if this is not a loop, this is a wire, open wire, and you have to calculate force acting on the wire. So how you will calculate L vector? You will combine end point to uh, starting point to end point, and this combined length will give you, like if you're going to combine point 1 and 2, so you're getting a length here L12 and this is L vector. Okay, how we will solve closed loop questions, force acting on closed loop? So if closed loop is placed in a uniform magnetic field, in that case force acting is zero. Why? Just to see here, suppose I'm taking this strip of dl vector. So here current is flowing in this sense, so direction of dl vector is in this sense, right? So this is dl vector, and on it force will act in which direction? If this direction you are taking as minus I cap, so you will write like minus I cap cross minus K cap. Okay? So you are going to get some direction from here. Now, if I'm taking just another strip opposite to it, if this strip I consider, here current flowing will be in this direction. Then, so DL vector is in this direction. Magnetic field is same, that is minus K cap. So force acting on this strip will be in which direction? If I talk about simply direction, then I L cross P. So direction will be L cross, L is I cap cross minus K. So here force acting is minus I cross minus K. So if you're going to find out the direction, I cross K will be minus J. So here the force acting will be along minus J, that is this. And here the force acting will be plus J, this. And since magnetic field is uniform, here also force acting will be IDLB, and here also force will be IDLB because B is same throughout. So these two forces are equal and opposite in direction, they will cancel out. So the thing is, I have explained already कि if closed loop is placed in a uniform magnetic field, force is zero. And if that is not kept in a uniform magnetic field, force will be non-zero. And here what the question is, there is a current closed loop and that is placed in the region of magnetic field. Then force and torque acting on the loop. In the question, it's not given field is uniform or not. But by looking at the picture, we can see that magnetic field given here is uniform because distance between field lines is constant. So this is a uniform magnetic field. And if field is uniform, just close your eyes and write the answer. Force acting will be what? Zero. Now the question is of torque. Torque कैसे निकालते हैं? So torque is M cross B. M is what? M is what? IA. So current flowing in the loop into area vector. Question is, what is the direction of area vector? So area vector direction निकालने के लिए, you just curl your right hand finger along the direction of current. So current is flowing in this sense. If I am going to curl my finger, my thumb will give me the direction of area vector and that is outward. So area vector is outward, magnetic field is in this sense, angle between area vector and magnetic field is how much? 90 degree. So definitely torque is not going to be zero. It will be non-zero. So correct answer will be what? Force zero, torque zero? No. Force zero, torque not zero? Yes. Force is non-zero? नहीं. Force zero होगा क्योंकि this is a closed loop placed in a uniform magnetic field. Okay. I hope this is clear. Now let's move on to next question, equivalent resistance between the points A and B. Now this question is very common, very much easy. You must have came across such kind of questions. But why I included this question is because I wanted to make you understand if the question is not this simple, what will be your approach towards solving this question, okay? So what you need to do is just give this circuit, like just take some points, or just give every point a name in terms of potential. What I'm trying to say is, so this is a point, this is a point from which registers are coming out. Done. So we need to name this point with respect to potential. So we have to calculate potential difference between A and B. Whenever in the question it is given that you have to calculate potential between 2 points, just do one thing, connect the battery across those 2 points. So I have done this job now. Potential of A will be same as potential of this, and between A and this point, there is uh, no instrument or nothing that can draw the voltage. So whatever potential is of A, same potential will be of this point. So in terms of potential, this point will be A. Then, so in terms of potential here also, this point will be B. Now let's name other points from which registers are coming out in terms of potential. Again, this is the point from where registers are coming out. Done. And A and this point won't be same in terms of potential because there is a resistor in between on which potential will drop. So this is going to be a different point. Call it C. Similarly, from this point also, registers are coming out. Done. So this is kind of a junction. We need to name junctions in sort. You just see here, this point is also different from A, C, B in terms of potential. Call it D. So in terms of potential, we have named all junctions and we have got 4 points A, C, D, B. So do one thing. A, B को आप ऐसे लिख लो, C, D को आप space में कहीं भी रख लो. I have, with experience, I have kept it like this. Okay. You can keep it anywhere and you will get the answer. So now start putting resistance between points. So between A and C, there is one resistor. Put it here. Between C and B, between C and B, yeah, between C and B, this register is there. So again, there is one register between A and D. Between A and D, this register is there. So put it here. And between D and B, this register is there. Put it here. Now, C and D, let's see if there is any register between C and D. Yes, there is one, this. And we have to calculate equivalent resistance between these 2 points. So question is this simple now, okay? And this is a Wheatstone bridge. This is a balanced Wheatstone bridge. You can see because resistance values are equal like this. So R by R is 1, R by R is 1, ratio is equal. This is a balanced Wheatstone bridge. And if Wheatstone bridge is balanced, no current will flow through this. RR will become 2R. This RR will become 2R. So this question will become like, this is 2R, this is 2R, and this is point A, and this is point B. ठीक है, 2R are in parallel, so 2R in parallel will become R, so answer will be what? R. So correct answer should be what? D. Now let's move on to next question. So there is a square coil of side 10 centimeter. So there is a square coil. This is a square coil, right? And its side is how much? Its side is 10 centimeters. So let's mark everything here. Its side is 10 centimeters. So its area will become how much? 10 centimeter ka square. So if in meter square I write it, it will become 10 to the power minus 2 meters square. Okay. And it carries how much current it is given. It has 20 turns. And this is not a single turn coil. It has 20 turns. Each turn is carrying a current of 12 ampere. The coil is suspended vertically, so it is suspended from certain point and normal to the plane of coil makes an angle theta with the direction of a uniform horizontal magnetic field of 0.80 Tesla. And it is suspended from that point in such a way that normal to this coil is making an angle of theta with the magnetic field. Yani ki normal to the coil means area vector. So angle between area vector and magnetic field is how much? Theta. Okay? Now horizontal magnetic field value is given 0.80 Tesla. Now if the torque experienced by coil equals torque value is also given, that is 0.96 Newton, then value of theta is. So simple, you need to put the formula, get the answer. So put the formula here. Torque is how much? M cross B. Now what is M? That is I, A cross B. A is the area vector and direction of area vector is normal to the plane. Now normal to the plane, you will get two direction, outward and inward. So which direction? In that case, we just now in previous question I have told you, curl your finger, your right hand finger in the direction of current. In which direction? Just see in which direction your thumb is pointing out. That will give you the direction of area vector. So in short, area vector is normal to the plane. Which direction, inward or outward, that you can ascertain, that you can find out by using right hand thumb rule. Okay. चलो यहाँ पे that value is given, so no need to worry about it. Now IAB sine theta, and that is equal to torque. So this torque is acting on a single coil, and here we have how many coils? N turns. So in total torque will be this into N. So this is the total torque formula. And in the question, torque acting, that is total torque, is 0.96 Newton. Now, start putting the values. A is your 10 to the power minus 2. I is your 12 ampere. Magnetic field is your 8 into 10 to the power minus 1. And N is how much? That is 20 sine theta. Sine theta we need to calculate, right? Now, let's see the values. This is by 100, okay? So, this will become how much? This will get cut by 12 times, okay? And here also there is a 12 term, so 12, 12, it got cut. Now what is remaining is sine theta will become equal to, if you see here, sine theta will become equal to 1 by 2000 into this 10 to the power minus 3. If that will go this side, then it will become 10 to the power 3. So this is equal to half. Sine theta is half. Theta will become equal to how much? 5 by 6. So correct answer will be 5 by 6 then. So that is your correct answer. Now why I included this question? Actually, this question is not correct. First, let me tell you. But still I've included it because I wanted to make certain things clear to you. Now, this is a case of convex mirror. So there is a convex mirror and its focal length is given. And it's given that this convex mirror produces a real and inverted image of magnification 0.5. This is given, right? Now, you all have studied convex mirror, and we know that convex mirror looks like this. And it always forms, as we have studied in class 10, it always forms what sort of mirror? Sorry, what sort of image? It always forms image that is virtual and erect. So image getting formed by this is what? Virtual and erect. Okay? Virtual and erect. But in the question you just see here, image getting formed is real and inverted. Is it possible? So in class 10th, our knowledge was up to this. In ray optics also, I have explained you the concept of virtual object, not image, virtual object. And that virtual object concept can explain convex mirror can form real image. How? So here, if there is light coming from somewhere, it doesn't seem like here, if light is falling on convex mirror like this, you can't see the object. So you can't see from where light is coming. But if we extend incident light, it will meet principal axis at certain point. And this point we will call as virtual object. So this is your word, virtual object. And if this is the case, then image getting formed by convex mirror will be real image. Then, so first statement is somewhat, it is true, it's not wrong. So according to first statement, question is correct. But where this question went wrong is by how much distance objects should be brought closer to obtain the virtual and erect magnification. Now, with the help of convex mirror, we can't form like by how much distance objects should be brought closer to obtain the virtual and erect image. So for the same object it is talking about, by what distance this object we should move so that we will get virtual and erect image. Now the question is, if object is virtual, image form will be real always. Done. In that case, image getting formed can't be virtual. So this second statement can't be explained. This is wrong. And that is why this question is wrong. Because if object is virtual, no matter what the nature of images, convex mirror, concave mirror, no matter what it is, image getting formed will be real. But if object is real, image getting formed is virtual in some cases, real in some cases. But with the case of virtual objects, image getting formed is always what? Real. So if first statement is uh, true, like is written as it is, then second statement can't be true. I mean, if object is virtual, then we can't get virtual image in any case. Done. So that is why this question is wrong. Again, I included it just because I wanted to again explain the concept of virtual object. Okay, chalo. Now let's move on to this question. So in this question, what is happening? There are two coils, A and B as shown in the figure, and current is flowing. Then current starts flowing in B as shown when A is moved towards B. Now, there were two coils, A and B. Okay? They both are in rest. But what happens? When A is moved towards B, then current starts flowing in B. So this is a case of mutual inductance, right? If there are two magnets, no, not two magnets. Suppose there is a single magnet, south and north pole, then, and there is a coil. If we are moving this coil like this, what will happen? Current will flow in this coil. Why? Because magnetic flux through this coil will change. So if flux is changing, EMF current will flow because EMF will get generated. We have learned this formula. E is equal to minus d phi by dt. Done. So here also, if A is moved towards B, current starts flowing in B. It means A has current flowing in it. And current carrying coil behave as a magnet, right? So here it's moving towards B, then current is flowing. If it stops moving, it is given in the question. If A stops moving, no current flows in B. It means A has current flowing in, and it's also given in the question, current is flowing in counterclockwise direction, in this direction. So we don't need to worry about direction, it's given already. Now, what we can infer from here? Then, so you can see that we have seen in Faraday 3 experiments that there are two methods of generating current in adjacent coil or adjacent coil. Those three methods were like what? In first case, what we did in first case was this. In first case, we took a magnet and there was another coil. We were moving magnet towards or away from the coil. Current was getting generated. In second case, what we did, we took a current carrying coil having constant current and we moved it towards the coil. In that case also, current was getting generated. And in third case, we were not moving the coil. We took a stationary coil, but here we made current variable. Okay? Current variable. And then there was an adjacent coil. In this case also, current was flowing. Why? Because this has a variable current flowing in it. And so it will have a variable magnetic field linked with it. And that is why variable magnetic flux will get linked with adjacent coil also. And if there is a variable magnetic flux, EMF will get generated. So for variable magnetic flux, if current is constant, we need to move the coil. If current is variable, we don't need to move the coil. Here, if we are not moving the coil, current is not flowing in B. It means A has constant current flowing in it. So correct option will be. There is a constant current in the clockwise direction in A. It is given in the question, current flowing is in anti-clockwise direction. So this statement can't be true. There is a variable current in A, not. There is no current in A, no. There is a constant current in the counterclockwise direction. Yes. Okay. So this is our answer. Now let's move on to the last question. Calculate the angle of minimum deviation for an equilateral triangular prism of refractive index root 3. Now, prism is of what sort? It is equilateral triangle form, right? So equilateral triangle means 60 degree everywhere, all angles. So angle of prism must be 60 degree. Over. Now, let's see, this is incident angle and it's given incident light, sorry. Draw normal here. It is given in the question, we have to calculate minimum deviation. When minimum deviation happens? When I is equal to E. What is I? I is this. What is E? E is your this. And if I and E is equal, this R1 and this R2 are equal. We have studied it recently. So R1 will be equal to R2. And we have also studied that R1 plus R2 happens to be equal to A. That is 60 degree here. So if I write R1, R2 as R, then 2R will become 60 degree, R will become 30 degree. So angle of reflection for first surface or angle of incidence for second surface is 30 degree. Now, what we need to form is deviation. What we need to calculate is deviation. So formula of deviation will be how much? I plus E minus A. Okay. Now I is equal to E. A we already know 60 degrees. I we don't know. Okay. So let's apply Snell's law here on the first surface. So if we apply a Snell's law, mu air into angle of incidence, that is sin I. So 1 into sin I will be equal to mu prism, that is root 3 into sin R, sin 30. Sin 30 is half. So root 3 by 2. Again, I will become equal to 60 and I is equal to E. So this will become 120 degree. Now 120 minus 60 will give you the answer. And so answer will be what? Answer will be your 60. Then, so correct answer will be D. I hope all questions are clear that I explained. But if you feel like I have left some questions that you were having doubt in, you can send it to our team and I will be very happy to send you the solution. Okay. And yeah, purposely I left some questions, those questions which are coming from the chapters which I have not taught yet. So I thought like I will be teaching those chapters in recent days. So that will get clear there. That is why I didn't explain because you have not gone through the chapter. And I felt like if I try to explain it, it won't be justice because you're not background of that chapter. That is why I left. But those are only few chapters, one or two. So that we will cover. No need to worry. All the best, everyone. And keep attending test. Please don't ignore any test. And after attempting test, when you come back to your home or house, whatever, uh, you just try going through all the questions and going through all the questions mean question you were having doubt in. Okay. So I hope you will do all these things. Don't worry, don't take tensions, only read and stay positive. Bye bye, take care.